The echoes function can detect and display the echoes that can occur due to multiple reception of the same digital terrestrial DVB-T, T2, ISDB-T or ATSC 3.0 channel with different delays. These additional signals received with some delay are called echoes and can occur due to different reasons. In multi-frequency networks, the only source and cause for the appearance of echoes is the reflection of the main signal being broadcasted by a transmitter in buildings, mountains, etc. In single-frequency networks, echoes can be caused as well by reflections on mountains and buildings, but here there is another possible source of echoes, which is the same signal being received from a different distant transmitter. For in SFN networks, all the transmitters within the network broadcast the same contents in the same RF channel frequencies simultaneously. The underlying idea behind the use of a guard interval in DVB-T, T2, ISDB-T or ATSC 3.0 terrestrial broadcast is that, knowing echoes will appear for the reasons mentioned, this guard interval or pause time after transmission of a set of symbols will allow these echoes to fade away and do not affect the signal reception of the next set of symbols being received from our main signal. On the left side, we can see an echo received with a small delay after the main signal. Thanks to the guard interval, the echo will not affect severely the reception of the set of symbols from the main signal. However, on the right, the echoes are received with a greater delay, actually greater than the guard interval, and therefore the reception of a specific set of symbols k-1 will severely interfere the reception of the next set of symbols k from the main signal path. Now, the echoes analyzer featured in the ATLaS analyzer is a formidable tool in order to visualize these echoes and assess the potential damage they may cause to our signal. This graph is showing time in microseconds in the horizontal axis and level in dB carrier units in the vertical axis. As many as 10 echoes can be displayed simultaneously in the graph. Everything falling in between the red areas are echoes being received within the guard interval, whereas everything falling in the red areas is outside the guard interval and therefore very damaging. For each echo, we can read its related level when compared to the main signal, its delay in microseconds when compared to the main signal, and its distance in kilometers to the source compared to the main signal's distance to the source. If we press on the cog at the top right corner of the Echoes Analyzer panel, we will find an option to zoom in the graph. Pressing one of the table columns will make the corresponding echo in the graph to be highlighted in blue color. In this way, we have very detailed information to identify the cause of a bad signal reception, when other measurements such as power level, carrier to noise, etc. seem to be okay. The installer exposed to these echoes can only play with the location and orientation of the receiving antenna in order to minimize the negative impact that these echoes can have on signal reception. The antennas commonly used in TV reception installations are Yagi type and have a radiation diagram like the one in the figure. If we have our antenna aligned as in the picture, so that we receive a maximum signal level, good carrier-to-noise ratio, MER, etc., we will need to rotate the antenna to minimize the effect of the echo and to make it fall outside the main and secondary lobes, but being careful not to degrade too much the main signal.